third lecture of example based on continuous beam. Okay, so students, in the first lecture we will discuss about our example number 1 and example number 2. Okay, so in example number 1 it is clearly mentioned that you have to find out collapse load. It means you have to find out WC for two span continuous beam, and this both the span is subjected to point load. Okay, so this example is covered in our first lecture. After that we will discuss about the second example, but the major difference between example number 1 and example number 2 is that in the first lecture you have to find out collapse load, and in the second lecture you have to find out plastic moment. Okay, so this is the question of second example. So these two examples will be covered in our first lecture. After that, we will discuss about our example number 3. Now, what is the difference between example number 1, 2 and example number 3? So, in example number 1 and 2, you can see that your both the loads are considered as your concentrated load. Okay, so you can see that on the span AB and on span BC you have to act, and you have to consider that your load acting is your point load. Okay, and this point load is considered as your factor load. Okay, so in the third lecture you have to solve this example in which your left support is hinge support, your centermost support is considered as your intermediate support, and this intermediate support is considered as your fixed support, and your right support is also a hinge support. Okay, and on these two span you can see that on the left span point load is acting, and on the right hand span the UDL is acting. So first of all, in the last lecture we will discuss about our case number 8. So first of all, we have to derive one equation of find out plastic moments for propped cantilever beam subjected to UDL throughout the span. Okay, so this is your case number 8, and the derivation of case number 8 is WL square divided by 11.656. Okay, and after completion of this derivation we will move further to our example number 3 in which there is two span. Okay, so this slides is covered in our last lecture. Okay, now we are moving further to our fourth example. So what is the difference between last lecture and in this lecture? So you can see that in this figure, this is the first example in which your both the span is subjected to UDL. Okay, so now we are moving further to our example that a two span continuous beam is loaded as shown in figure. So you can see that this is your two span continuous beam which is subjected to UDL throughout the span, and the value of UDL is, the value of dead load is 20 kilonewton per meter, and your value of live load is 10 kilonewton per meter. Next is take Fy. Now what is Fy? Fy means yield stress. Okay, you are already studied the term Fy and Fu in your semester 6 in EHD subject, in which there are two portions, RCC and steel. So in steel portion you have to take the value of Fy is 250 and the value of Fu is 410 megapascal. Now megapascal term is also called as Newton per mm square, because 1 megapascal which is equal to 1 Newton per mm square. Okay, now given load is working load, It means this dead load and live load is your working load. So whenever you have to design any beam, then you have to design it for factor load. Okay. Now it is already discussed in our introductory session that whenever in plastic design chapter there is no any factor of safety given, then you have to consider that your factor of safety, or it is also called as load factor, is equal to 1.7. Okay, so now you can see that your both the span subjected to 20 plus 10, which is equal to 30 kilonewton per meter. So first of all, we are moving further to the calculation of span AB. So what is the factored collapse load? So our factored collapse load is 30 into 1.7, which is equal to 51 kilonewton per meter. Okay. So over here it is kilonewton per meter, not kilonewton into meter. Now what is the equation of MP? So whenever your one support is hinge support and another support is fixed support, it means this case is your case number 8, in which the prop cantilever beam subjected to UDL throughout the span. So you can see that in this figure, this is your hinge support, or it is called as this is your simple support, and this is your fixed support, and you can see that your UDL is acting throughout the span. So whenever the prop cantilever is there, the equation of MP is always WL square divided by 11.656. Now, what is the value of W? The value of W is 51. The value of L is equal to 8 divided by 11.656. Then you will get your answer 280 kilonewton into meter. Okay. So this is the calculation of your first span. Now you can see that in this figure that this is your intermediate support, and your intermediate support is considered as your fixed support, and this is your simple support. Now what is the span? So the span is 8 meter and load is also remain same. So you can see that your this example is the symmetric figure of one another. It means your answer of span AB is equal to your answer of span BC, because this is our symmetric figure. So you can see that your calculation is remain same. Okay. Now there are two plastic moments are there, but you have to design any beam for maximum plastic moment. So one statement you have to return like this, that the larger of these two values is considered as the design plastic moment. So your value of MP is 280 kilonewton into meter. Okay. So students, this is the end of your example number 4. Now up to this example, we will discuss up to 4 examples, in which in the first 2 example we will discuss about point load. In the third example, one span is subjected to point load and another span is subjected to UDL. In the last example, you can see that your both the span is subjected to UDL. Now we are moving further for 3 span continuous beam. Okay, so our example number 5 is a 3 span continuous beam is subjected to load as shown in figure. Find out the required value of fully plastic moments for each span if a load factor is 1.7 at collapse. Okay, so first of all, we have to find out our factored collapse load. So this value for first span, the value of working load is 30. Okay, so 30 into 1.7, which is equal to 51 kilonewton per meter. So you can see that for span AB, our collapse UDL is 51 kilonewton per meter. Similarly, for span CD, your working load is 25 kilonewton per meter, then what is the value of factored load? So our factored UDL is 25 into 1.7, which is equal to 42.5 kilonewton per meter. And for center span, our center span is span BC, and if our value of working load is 60 kilonewton per meter, then our factored UDL is 60 into 1.7, which is equal to 102 kilonewton per meter. Okay. Now, in this figure, this example is very simple because you can see that your first span, span AB, in which your support at A is your simple support and support at B, which is your intermediate support. So this intermediate support is considered as your fixed support. So your first span is your case number 8, propped cantilever beam and subjected to UDL throughout the span. Okay. So your answer of MP is WL square divided by 11.656. Now, what is the value of W? It is 51. The value of L is 3 divided by 11.656. Then you will get your answer 39.40 kilonewton into meter. Now, similar calculation is for span CD because you can see that at support C, your support C is your intermediate support and your support D is your simple support. Okay, so your span CD is propped cantilever beam and your propped cantilever beam subjected to UDL of 42.5 kilonewton per meter. That's why your equation of MP is WL square by 11.656. Okay, so you will get your answer 22.80 kilonewton into meter. Now our last span is span BC. Now you can see that for span BC, your factored load is 102 kilonewton per meter and your both the supports are fixed now. So whenever your both the supports are fixed, then you have to consider and you have to calculate for span BC with the help of kinematic method. Okay. So if your both the supports takes moment, so you can see that you have to convert your UDL to point load, and this point load is acting exactly at the center. Okay. So your capital W is equal to small w into L. So it is 102 into 3, which is equal to 306 kilonewton, and this 306 kilonewton is acting exactly at the center. Now your external work done is equal to load into average deflection. Okay, now your load is 306 into average deflection. So you can see that your center is at 1.5 meters. So your 1.5 theta divided by 2. So it is 0.75 theta. So it is 229.5 theta. Now your internal work done. So you can see that in this figure, at this point it is fixed support. So yes, this fixed support takes moment. This is at the point of load. So yes, this point is also takes moment. So it is MP into 2 theta. And this is your C support, and your C support is your intermediate support, and your intermediate support is considered as your fixed support. Okay, so your all the points is takes moment. So your total internal work done is 4 MP theta. Now your both the terms, external work done and internal work done, is in the form of theta. So your final answer of MP is 57.375 kilonewton into meter. Now you can see that there is three answers are there. Your first answer is 39.40, your second answer is 22.80, and your third answer is 57.375. Now, you all know that larger value is considered as your plastic moment. So, our final answer of this example is larger value of these three value is considered as your plastic moment. Therefore, your MP is equal to 57.375 kilonewton into meter. Okay. So students, this is the end of today's session. Thank you.